Okay, this is question 11. Right, so what we know is that the integral evaluated from 0 to a of e to the power of 1 minus 2x is e divided 4. and we have to solve for a. So up here it might be a bit hard to see. That's unknown a. So we're going to need the antiderivative for this, fundamental theorem of calculus. The antiderivative of e to the 1 minus 2x, well, then I need to divide by, so it'll be minus a half. Alright, that should be fine. We're evaluating it between 0 and a, so that will look like this, minus a half e to the 1 minus 2a minus a half e to the 1 minus 2 times 0. Now 2 times 0 is just 0, so that'll be 1 minus 0. It's just e to the power of 1, which is e. And I've ended up with a minus minus. Be careful with this. Sometimes you want to be writing the second part of fundamental theorem of calculus. You know, when you're doing your antiderivative, write this one in brackets, and it will hopefully, especially if there's more than one term, there's only one thing here. But I've got to be careful that minus minus is the same as adding, according to the rules of maths. So just be careful with negatives. Right? And I know the answer. They told me the answer at the start. It's e on 4. One thing I don't like at the moment is these fractions, half and half. So I think I'll come through all times by 2. I'll say minus e to the 1 minus 2a plus e equals, times everything by 2. Don't forget anything. E on 2. Right? Now the other problem that I'm seeing is that the a is locked up in a fairly complex power. We've got e to the 1 times e to the minus 2a. Right? So if I rewrite it as this multiplication, e to the power of 1 times e to the power of minus 2a, so it's still the same thing. You know, index laws, adding powers. And then we can factorise our e. I think we have something that looks a bit easier to work with. Although, would it matter much? Yeah, I'll do it this way. So we'll get, oh, that's another interesting idea. I might factorise out minus e. And we'll be left with e to the minus 2a. And just be careful, if I'm pulling minus e out, this is plus e, so that will now need to be minus 1. Right, so I'm doing a factorising, pulling out e. I decided to pull out minus e actually. Right. So this and this are now the same. Now, what we could do here is we could divide both sides by e. Right. This is half e over here. If we divide by e divided by e, that will simplify things nicely for us. We've got e to the minus 2a minus 1 equals a half. Right? I've got a 1 and I've got a half. So let's add 1 to both sides. There's no, why would you leave that alone? You wouldn't. And now to solve this, I'll need logs. Oh, hang on, so I've made a mistake. When I divided by e, that was still negative. Let me fix that. Sorry. Up at this step, I wanted to divide both sides by e. I'm going to divide both sides by negative e. That way, I'll be left with this being positive here. So I'm going to divide by minus e. If I divide that by minus e, this will be minus minus a half. So lots of negatives in this question. Got to be careful. Then I'll add 1 to both sides. That's better. Right. Now at this point I just need logs. So if we use the natural log, we bring in log there, we bring in log here, you'll know something's gone wrong if you're trying to log a negative number, because you can't do that. So our next line of work would be logging both sides, and log is, the natural logarithm is the inverse of e to the x, so this will just leave us with minus 2a equals, now this is log of 2 to the minus 1. You might want to use the log law that says you can bring a power out. So log to the half can actually be rewritten as minus log 2, which would be nice, because then I can say that 2a is log 2. Therefore a is half of log 2. Or if I want to be really fancy, I could use my log law again. I could say, look, it could be log 2 to the power of a half. The power of a half is square root. So I would give that full marks, I think. But you could also write your answer like that. Okay, done.